Okay, in this video we'll cover something called converting from octal to decimal, or how can we convert from octal to decimal. Why we need that? Because decimal is the number that we are dealing. Octal is the thing that usually machine dealing. Not sure all machines or some kind of machines, but it's very important to understand how some machines and people dealing with each other according to the numbers that they are dealing with from different words. Okay, first, what's octal? Octal is a number. So this is a number. So usually we have 1 digit, 2 digit, 3 digit, or bit, sorry. This 4 bit. Each bit is represent a number, but according to octal system, each bit doesn't cross more than, or it doesn't it cannot be 8. It usually become like 7 maximum. Then when you add more, it will be something above. You will go to the next digits. So let's take this one as example. This is the first bit. So this, let's assuming it's 7, and this is nothing there, or 0, and we add just 1. So this one will be 0 here, and or actually it will be 8, but we will remove 8 because it's octal number and put 0 instead, and here we will put 1. So 10 in octal mean 8 actually in decimal. Okay, let's say if we have like let's see 6 and we add 2, or let's see 6 and add 3. In decimal word, when you add the 3 to 6, it will be 9. So 9 actually here will be something like, it will take 8 and make it 1 here. So what's the rest is will be 1 will be here. It is an octal number, will be 1 here and 1 here. So it's almost, or it's 11, but in octal system. So in octal system, 11 mean 8 plus 1, which is 9 in decimal word. Okay, so every digit or bit, let's say, is less than 8. So when you want to make sure your conversation is wrong or right, the octal number usually when you you convert it to decimal, it will be less. So this one in the decimal number or decimal equivalent, it will be less than the octal number. So this is a good example. We want to convert it from octal. You see, like we put it between 2 parentheses and 8, and this line is showing the bit, and this is converting that to decimal. So we put it between 2 parentheses and 10, and this is the point of fraction. If you see it here, it's in blue. So this one bit, this is bit, this bit. This is the first bit, second bit, third bit, and this is after the on the right side of the fraction points. So it will be first bit, second bit. Okay, now how can we convert? First, we'll put each number in bits in a different or dealing this with a different way. So this is the fraction. This is the fraction. We just move it here and put it here. So this is 5, and this is it's what's equivalent. So we'll take this 5 and multiply it by 0, plus 7. We'll take it here, multiply it by 8. You see it's power with 1 here and 0 here, and this is with 2. So the first one we use 8. We multiply whatever number we have with with this 5 or this number with 8 powered of 0, which is 1. Then we go to this one and we multiply it by 8 powered of 1. Then we will take this one and multiply it by 8 power of 2. And if we have another, let's say another bit, we'll multiply whatever number we have here. We got here with 8 powered of 3, and so on. So this is 5 multiplied by 1 here, which is equal 5, and this is 7 multiplied by 8, and it will be something like that. It will be 56, and here 8 power of 2, it will be 64 multiplied by 3, it will be 192. So we'll add all this together. You see it here again. We'll get something like that. So the fraction, we will make it the next step. So we'll go back here to the fraction. So the first number in the fraction here in the right side of the fraction will multiply by 8 minus 1. Then we will add it to 1 multiplied by 8 minus 2. So 5 multiplied by 8 minus 1, it will be 5 divided by 8, which will equal this number, which is 0.63. Okay, sorry, here. Then we will do this one. So 1 multiplied by 1 over 8 power of 2 will be something like 0.02. So when we add all this together, or here, let's say, we'll get something like that, 65. So this is, you can use it and put it here. So this one equal here. And you notice from this rule, this number is bigger than this one. And it's very obviously why. Because 8 will be fold before this one, before 10. So you know, in decimal, when we add, in the first bit we need to have 10 numbers to move to the next bits. So 9, it can be in 1 bit, and when you add 9 to 1, or you add 1 to 9, sorry, you will get 0 in the first bit, then 1 in the second bit, which is representing the 10. Here is the same. 8 will be fold faster in the bits. So it will fold when it's 7, like we just show in that example. So when 7 added, when you add 1 to 7, it will be very easy to jump to, way easier to jump in the octal to the next bit before the decimal. And this one, because it's actually look like bigger than this one, but actually it's the same, because this one is 8 in the octal system, this one in the decimal system. Thank you for watching this video.